In the diagram, M is the mass of a body which is suspended by an inextensible string, and this inextensible string passes over two fixed pulleys A and B. The string is inextensible, and this string passes over two fixed pulleys, and these two fixed pulleys are A and B. A body of mass capital M is suspended by using a string which passes over two fixed pulleys A and B. These are the two fixed pulleys A and B. P and Q are the two free ends of this inextensible string. P and Q are the two free ends of this string. Q and P are the two free ends of the string which passes over two fixed pulleys A and B. When the two free ends P and Q of the string are pulled downwards with the uniform speed U, the mass capital M, which is suspended, will move upwards with the uniform speed V. U is the uniform speed with which the two free ends P and Q of the string are pulled downwards, and V is the velocity with which the mass which is suspended will move upwards. If the two free ends P and Q are pulled downwards with the uniform speed U, if the two free ends P and Q are pulled downwards with the uniform speed U, the mass M will move upwards with the uniform speed V. Now we can denote the length of the oblique portion of the string, that is L is the length of the portion OA. L is the length of the portion OA. Similarly, on the right hand side, L is the length of the portion OB of the inextensible string. Now we can denote the distance of the mass from the fixed point N, that is Y. N is the fixed point and Y is the distance of the fixed point N from the mass M. So Y is the distance, vertical distance of the fixed point. X is the distance of the fixed point N from the pulley A or B. A or B. So here L is the oblique length, Y is the vertical distance, and X is the horizontal distance of the fixed point N from the pulley. Now Y is the distance of the fixed point N from the mass M. Now X is the distance of the pulley A from the fixed point N. Similarly, X is the distance of the pulley B from the fixed point N. The oblique portion of the string, that is the portion OA, makes an angle theta with the vertical. Similarly, theta is the angle subtended by the oblique portion OB with the vertical direction. So theta is the angle subtended by the portion OA with the vertical direction. Now what will be the question or topic? In the arrangement shown in the figure, two pulleys A and B are fixed. In the arrangement shown in the figure, the free ends P and Q of an inextensible string, the free ends P and Q of an inextensible string move downwards with the uniform speed U. String move downwards with the uniform speed U. Move downwards with the uniform speed U. The two free ends P and Q of an inextensible string move downwards with the uniform speed U. Pulleys A and B. The two light and frictionless pulleys A and B are fixed with the ceiling. The pulleys A and B are fixed with the ceiling. Here we have to find Now we have to find the velocity or the uniform speed or speed with which find the speed with which the mass M move upwards when the two free ends P and Q of the inextensible string are pulled downwards with the speed U. Find the speed with which the mass M moves upwards. That is, we have to find V, the expression of V. In terms of U, in terms the uniform speed U of the two free ends, let M be the mass, let M be the mass of a body, let M be the mass of a body which is suspended by an inextensible string, and the string pass over to fixed pulleys A and B as shown in the figure. Let M be the mass of a body which is suspended by an inextensible string, which is suspended by an inextensible string, by an inextensible string, and the string passes over, two fixed pulleys A and B as shown in the figure, such that y is equal to ON. Y is equal to ON, which is the distance of the fixed point N from the mass capital M. Y is equal ON, which is the vertical distance or of distance of the fixed point N from the mass M. Y is equal ON, which is the distance of the fixed point N from the mass capital M. And also here in the diagram, y is the distance of the fixed point N from the mass capital M. So here y is the distance of the fixed point N from the mass capital M, such that y is equal ON. And also we can write down the oblique length or length of the oblique portion of the string, that is L will be equal OA or OB. L is equal to OA or OB, which is the length of the oblique portion of the string connecting the mass with the two fixed pulleys. L is equal to OA. L is equal to OA, which is the length of the portion, OA or OB of the string. In the diagram, theta is the angle subtended by the portion OA of the string with the vertical direction. Theta is the angle subtended by the portion OA of the string with the vertical direction. In the diagram, theta is the angle subtended by the portion OA with the vertical. Similarly, theta is the angle subtended by the portion OB with the vertical direction. Now the two free ends P and Q of the inextensible string are pulled downwards with the uniform speed U. The two free ends P and Q of the string, two free ends P and Q of the inextensible string move downwards with the uniform speed U. That means the two free ends P and Q of the string are pulled downwards with the uniform speed U. 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 Therefore, U equal dl by dt. U equal dl by dt. That is the uniform speed of the two free ends of the string. Or U equal ddt of L. U equal ddt of L. That is the uniform speed of the two free ends of the string. In this case, the free ends P and Q are pulled downwards with the speed U, with the speed or uniform speed U, and the portion OA and OB of the string will also be moving with the uniform speed U, and L is the length of the portion OA. That's why the uniform speed U is equal dl by dt. U is equal dl by dt, where L is the length of the portion OA of the string that connects the body of mass M and the fixed pulley A. So finally we get U equal ddt of L, and here hence the speed with which the mass capital M, the speed with which the mass capital M or the body of mass capital M, which is suspended by using the inextensible string which passes over the two fixed pulleys, is given by the speed with which the mass M, which is suspended, moves upwards is V equal dy by dt. 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 That is the uniform speed with which the mass capital M will move upwards when the two free ends P and Q are pulled downwards with the speed U. Therefore, V equal ddt of y. V is equal ddt y or ddt of y. That is the uniform speed of the mass M. In the diagram, obviously the mass M which is suspended will move upwards with the uniform speed V if the two free ends P and Q are pulled downwards with the uniform speed U. The mass M will move upwards with the speed V, and the two free ends move downwards with this uniform speed U. From the triangle in ANO, from the triangle ANO, from the triangle ANO, L square is equal x square plus y square. L square is equal to x square plus y square, where L is the length of the portion OA of the string. Differentiating both sides with respect to time. Differentiating both sides or differentiating the above equation with respect to time, the above equation both sides with respect to time, we get ddt of L square equal ddt of x square plus y square, ddt of under bracket x square plus y square. From the triangle ANO, from the triangle ANO, the hypotenuse L, L is the hypotenuse, that means square of hypotenuse means L square is equal to x square plus y square. L square is equal to x square plus y square, which is derived from the triangle ANO, from the triangle ANO. Or comma ddt of L square equal ddt of x square plus ddt of y square, or comma 2l dl by dt, 2l dl by dt is equal to 0 plus 2y dy by dt. 2l dl by dt is equal 0 plus 2y dy by dt, where x is the distance of the pulley A from the fixed point N and this distance x is constant. This distance x is constant. X is the distance of the pulley A from the fixed point N, where x remains constant or x is a constant. That's why dx by dt. That's why dx by dt will be 0. If two free ends p and q are pulled downwards with the uniform speed u, in that case, obviously the mass m will move upwards with the speed uniform speed v, and the oblique length L decreases, and the vertical distance y also decreases, but the distance x remains constant. X remains constant. That's why ddt of x square will be 0. Ddt of x square will be 0. Or comma L or comma 2L dl by dt is equal to 2y dy by dt. 2L dl by dt is equal to y dy by dt. Or comma dl by dt is equal y divided by L dy by dt. Dl by dt is equal y by L into dy by dt. Or comma dy by dt will be equal dy by dt will be equal dl by dt whole divided by dl by dt whole divided by y by L. Dl by dt whole divided by y by L. Dy by dt is equal dl by dt whole divided by y by L. That is the uniform speed with which the mass m will move upwards. From the triangle ANO, cos theta is equal base by hypotenuse, which is equal y divided by L. Cos theta is equal to y divided by L. So from this triangle ANO, obviously cos theta is equal to y by L. Y by L is equal to cos theta. And that's why we can write from the above equation that dy by dt is equal dl by dt divided by cos theta. Dl by dt divided by cos theta. Or comma v is equal u divided by cos theta. V is equal to u divided by cos theta. V is will be equal to u divided by cos theta, and v is the uniform speed with which the mass m, which is suspended, will move upwards if the two free ends p and q of the string are pulled downwards. In this case, the mass m moves upwards with the speed v equal dy by dt, and the string moves with the uniform speed u, which is equal dl by dt. U equal dl by dt. Finally, we get v, which is equal to u divided by cos theta. V is equal to u divided by cos theta, and this is the uniform speed with which the mass m will move upwards if the free ends of the strings are pulled downwards with the uniform speed u. V is equal u divided by cos theta, which is the uniform speed, which is the uniform speed with which is the uniform speed with which v is equal u divided by cos theta, which is the uniform speed with which the mass m moves upwards. The mass m moves upwards provided the free ends p and q of the inextensible string are pulled downwards with the uniform speed u. V is equal u divided by cos theta, which is the uniform speed with which the mass m moves upwards if the free ends p and q of the string are pulled with the speed u downwards. if the free end P is pulled downwards with the uniform speed u, which is equal to dl by dt, the mass m will move upwards with the speed v is equal dy by dt, such that v is equal u divided by cos theta. That means v is equal u divided by cos theta. Now we can discuss the alternative explanation of this topic. So now we shall discuss the alternative process or alternative expression. That means later we can prove or we can find the expression of upward speed of the mass m in terms of downward speed u in terms of the two free ends of the string. Uh, that is, we are going to explain the alternative process or later. This case, if the two free ends P and Q are pulled downwards with the uniform speed u, the mass m will move upwards with the uniform speed v, and we can denote the tension acting in the inextensible string. Here T is the tension acting in the inextensible string. Similarly, T is the tension which is acting in the string which passes over the fixed pulley A. Tension T is the tension acting in the string. Similarly, we can denote the tension acting in the portion OA of the string, and also the tension acting in the portion OB. Theta is the angle subtended by the oblique portion OA or OB with the vertical direction. When the two free ends P and Q, when the two free ends P and Q of the inextensible string are pulled downwards, with the uniform speed u, in that case the mass m which is suspended, the mass m which will move upwards, with the uniform speed v, and the tension acting in the inextensible string, will be capital T. Tension acting in the string of the portion OA or OB is capital T. Now the tension, T acting in the vertical portion of the string, acts upwards, and the two free ends P and Q of the inextensible string will move downwards with the uniform speed u, and the free ends P and Q of the string move downwards with the uniform speed u. The two free ends P and Q of the string move downwards with the uniform speed u. The angle between the uniform speed u and the tension T is 180 degree, because u acts downwards and the tension T acts upwards. That's why angle between the tension T and the uniform speed u is theta, which is equal to 180 degree. Now the work done by the internal forces Work done by the internal forces is 0. And here we have a number of internal forces. The work done by the internal forces is 0. Is 0. Therefore, summation vector t dot vector x is equal 0, where x is the displacement and t is the internal force. T is the internal force and or tension, and x is the displacement. And the work done by the internal forces will be 0. That's why summation vector t dot vector x is equal 0, and vector t dot vector x is the work done, and that will be equal to 0. Differentiating the above equation with respect to time, differentiating the above equation, differentiating the above equation with respect to time, we get, with respect to time, we get ddt of summation vector t dot vector x is will be equal to 0. ddt summation vector t dot vector x is equal 0, is equal 0, or comma summation vector t dot ddt of vector x will be equal 0, or comma summation vector t dot vector v it will be equal 0, where vector v is the velocity, or comma vector t dot vector u plus vector t dot vector u plus vector t dot vector v plus vector t dot vector v is equal 0. Now, if we do dot product between the tension T acting in the vertical portion and the downward uniform speed of the free end P, then this is the dot product between T and U. Similarly, if we consider the dot product between the tension T in the vertical portion of the string and the uniform downward speed U of the free end Q, then we get vector T dot vector U, and that comes in the equation here. And if we do dot product between the tension T acting in the oblique portion way of the string and the upward uniform upward speed of the mass m, then we get vector T dot vector v, vector T dot vector v. Here this dot product between tension T and uniform upward speed v, we get vector T dot vector v, and that comes in this above equation. And if we consider the dot product between the tension acting in the oblique portion of the string and the uniform upward speed, then we get vector t dot vector v, that comes here, that comes here, or comma 2 vector t dot vector u plus 2 vector t dot vector v equal 0, or comma 2 tu cos 180 degree, 2 tu cos 180 degree plus 2 tv cos theta, 2 tv cos theta, which will be equal 0. Now the angle between the uniform downward speed u and the tension acting in the vertical portion of the string is 180 degree, because they are acting in the opposite direction. That's why we have considered tu cos 180 degree. Similarly, vector t acts in the oblique portion way and v acts vertically upward direction, and angle between t and v is theta. That's why we have written 2 tv cos theta. We have written 2 tv cos theta, or comma minus tu, or comma minus tu plus tv cos theta equal 0, minus tu plus tv cos theta equal 0, or comma minus u plus v cos theta is equal to 0. or comma v cos theta is equal u. Therefore, v is equal to u divided by cos theta. So in this way, we get the same result as before, where v comes as u divided by cos theta. V is equal to u divided by cos theta, which is the uniform upward speed, which is the uniform speed with which the mass m moves upwards. V equal u divided by cos theta is the uniform speed with which the mass m moves upwards. If the free ends p and q of the string are pulled downwards with the speed u,